talk about interest rates. And you may have come away with the idea from the last section that interest rates are these really simple things. It's just a single number that's sitting there. And it's far from the truth. Interest rates actually have a couple of different components that are associated with it. The first component you're going to have is that number, that nominal rate. So if you're used to thinking about 12% as being the full part of the interest rate, like we have right here, that's not entirely true, because it always has to have some kind of reference period that goes along with it. And so you're going to have associated with it something like, in this case, per year. Now, interest rates are not always per year interest rates. You may have some things like in credit cards, you'll have an interest rate that could be 2% per month or something along those lines. And you may also see things like CDs, which can be, like a 1.5% per quarter, something along those lines. So you always have to worry about that nominal statement. For the most part, the nominal period will be years if it is unspoken. That's an understanding that's there. So if someone says, oh, the interest rate is 6%, you can usually just assume that that's supposed to be an annual rate, at least in the United States. Now, the other number that's associated with an interest rate is going to be its compounding period. And this is the period of time over which interest actually earns interest too. There are conventions for various kinds of interest rates. Things like mortgages in the United States have the convention, unspoken often, that the interest compounds itself. Interest earns interest monthly. With savings account, it's common for interest to earn interest daily, so it has a daily compounding period. But it's one of those, very important numbers that are there to describe entirely what an interest rate is supposed to be. And this final bullet that I have down here, which is about that desired effective period. You can modify these three numbers into a composite number, which we're going to refer to as the effective interest rate. And what the effective interest rate allows you to do is compare interest rates, which actually have these three components. But the effective interest rate also allows you to do things like figure out what the payments are going to be of the loan. Since you can't take something which has an annual interest rate and say, well, whatever its daily payments, you have to find out what interest you're going to be paying over that individual day. So let's take a look at a couple of effective interest rate calculations. And I've started off here with three examples of interest rate. The first is an interest rate which you'd see as 12% annually compounded monthly. While 12% is kind of a high interest rate on a mortgage, it has the structure of a U.S. mortgage. And so that 12% is an annual interest rate, which we'll see for our mortgages, and it compounds monthly. So it has the right structure there. The second interest rate that I have right here is 2% monthly compounded daily, and it's kind of a typical credit card rate. Often if you look on your credit card contracts, you'll see that that interest rate will be something that's monthly, and they will tell you that interest earns interest on itself every single day. And then the one down at the bottom, the one that says 1 for 8 weekly, is something you would get if you borrowed money from slightly nefarious source. 1 for 8 means that if you borrow $8, you will in the next week owe $1 worth of interest. So we're talking about a 12.5% interest rate. And loan sharks will commonly compound this stuff weekly. So interest earns interest over a period of a week. Now let's look at these calculations that I have here. What I'm doing within the parentheses is I'm trying to figure out, ignoring the exponent that's right here, how much money I'll have in the account after one of the compounding periods. And so if you think about it as there's an implicit dollar that's sitting around on the left-hand side of this. And if I drop the dollar in the account, I still have the dollar. That's why the 1's there. And what I'm looking at right here, what this fraction is going to develop itself into, is the effective interest rate per compounding period. And what I've done here is I've taken that 12%, which is the annual rate that's right up here, and what I've done is I've divided it up by the number of compounding periods, months, in this nominal statement, annual. And so what I have within the parentheses is what would I owe if I put $1 into the account with this interest rate, and when it popped out the other side, that's how much would be accumulated. What I'm doing with the exponent right here is I'm trying to turn this into an effective annual rate. Now remember, you don't have to turn it into an effective annual rate. You could turn it into effective quarterly rates or effective monthly rates, or any number that's actually useful to you. What I'm trying to do is figure out, if I drop $1 into the account, what happens after that dollar would stay in the account for a full 12 months. And so what we're looking at right here is trying to accumulate interest on interest over 12 of those compounding periods. So the description I should have so far is, this right here is your nominal statement, 12%. This right here in the denominator is the number of compounding periods, months, in the nominal statement, which are in years. And this right here is the number of compounding periods in the desired effective period, which is annual. Now please remember, if anyone says, well, what's the effective interest rate, and you don't hear anything in between there, you can assume it's annual. Anyway, the 1 there, you just subtract that in order to turn it into an interest rate. And so this calculation says that if you drop $1 into this account, which compounds monthly and earns a 12% annual interest rate, the amount of interest that you'll have at the end of the year is 12.68% of whatever it is that you dropped into it. Now please note this is higher than just the 12 right there because you have the interest earning on interest for part of that period. The second number that we have around here, the second example, is a credit card rate. This is 2% per month, compounded daily. And what I've done is kind of gone through the similar procedure. There's that 1 for the dollar that you're dropping in. There's that 2% per month. And what this 30 on the bottom is supposed to be is a number of compounding periods, which are days, that you're going to find in the nominal statement, which is about there in months. So the thing in parentheses is what happens if you drop $1 into the account, what you'll have at the end of a compounding period, which is a day. Now because we're aiming for the effective interest rate, the annual one, what we're doing is just raising it to the power of 360. And we've declared that 360 is going to be the number of days in a year. What's kind of critical about this is that you often have to check the contract to see exactly what are the relationships between days, weeks, and months. And we'll have a contract in class that says things like there are 7 days in a week, there are 4 weeks in a month, there are 30 days in a month, there are 360 or 365 days in a year, there are 52 weeks in a year, and so on down the line. Now not all these will be consistent with each other. You basically try to take the short path through. You have to do this in real life. Check the terms of the contract because you will see some funny things in there. I've seen contracts that said that there are 350 days in a year, 360, 365. It does bounce around and you have to check those definitions. Now the key thing to remember, though, if you're looking at what your ending result here is on that compound interest rate, is that while it is 2% per month, you just can't go ahead and multiply by 12 and get the number 24 because your interest earns interest on a daily basis. So that effective interest rate is a little bit higher than just multiplying that monthly rate by 12. Now the interest rate that should really interest you is this Loanshark rate. And essentially what we've done is we have that 1 there. This 12.5% is the interest that you have to pay over a week. So 1 for 8 is 1 divided by 8. The compounding period is weekly. Well, it's also a weekly statement. So it's how many compounding periods, weeks, are there in a week? Well, there's 1. And because we're looking for the effective annual rate, there are 52 weeks in a year. And you end up with this really outlandish interest rate on loan sharks. And again, this assumes that they're able to keep the money always in circulation, earning a little bit of interest. Now just to go ahead and set it all up in general again, if you take that nominal interest rate I, so this could be 12% per year, this could be 3% per week or something along those lines, and you divide it by the number of compounding periods in the nominal statement, what you end up in parentheses is going to be the effective interest rate per compounding period. A very simple thing. Raising it to the power of r, basically what it does is allows you to convert a single compounding period and turn it into multiples of those compounding periods. So if you took something which had a compounding period of a day and you wanted to turn this into an effective monthly rate, up here in the exponent you'd put 30 because there are 30 days compounding periods in your desired effective period month. If you wanted this to be a quarterly rate, you could go ahead and put a 90 up there because there are 90 compounding periods days in your desired effective rate, which is quarters. And that's the basics that you're going to have for the effective interest